Well, we looked at a bit of addition, some subtraction, multiplication, division, sort of went, meh. There is one other operation that we can do with functions, and that's called composition. This is unlike anything we have done in previous units. With composition, we are going to take a function and substitute it into another function. It's like inception, but in math class. A bit of color is really helpful here. If you have highlighters, I recommend using them. If you don't have highlighters, colored pencils can work, different colored pens. I'm going to make my f of x green and my g of x blue for this example here. So note there's a new notation. It's this little open circle. Looks like multiplication, but it's hollow in the middle. F of g, again using my colors that I've chosen here, that little open circle is usually pronounced of. We are taking f of g. What that means is we are going to take the function f and we are going to evaluate it at g of x. So we're going to take g of x, which is an entire function, and put that into f, which is itself a function. We are putting a function into a function. Note the order here. G was closer to x, so g is going to be evaluated first. And then we would do f. If for some reason we were composing 3 or 4 functions, we would do them in the order that they show up in the notation. Order does matter here. We think about pizza, and we let f of x be a pizza and g of x be a pineapple. F of g of x means we evaluate g of x first. In other words, we're taking pineapples, like we have here, and putting them onto a pizza. Because g of x represents pineapples and f of x represents pizza. The pineapple goes into the pizza. This is very different from g of f of x. That would mean we are taking pizzas and putting them on a pineapple. That's weird. Order matters with composition. Make sure you're following the instructions that are given. The variable that is the closest gets evaluated first. So let's take a look at number 11 here, f of g of x. So what that means is we need to look at g of x first. I'm going to go ahead and use the same color scheme I did before. I'll let f be green. So what we are talking about here is doing f of g of x. In other words, we are going to find f of g of x, and g of x is x minus 1. So all of x minus 1, this entire function, is going to get substituted into f. F is this x cubed plus 8. So what that means, we are going to take x minus 1, and it's going to be cubed, and then we're going to add 8 to it. So the green there represents f, the blue represents g. I am taking g and substituting it into x. At first glance, man, that looks like a ton of work, doesn't it? X minus 1 cubed. Oh, that means we have 3 of these x minus 1s. And then we're going to add 8. So it's 3 x minus 1s, and then we're adding 8. Keep in mind, this is a FOIL problem. It's not too terrible of a FOIL problem, but we're going to have an x times x, which is x squared. We're going to have x times negative 1, which is negative 1x. That'll happen again for my inside terms. And then negative 1 times negative 1 is a positive 1. So multiplying those two binomials does give us a FOIL problem. Combining like terms there, negative 1x minus another 1x is negative 2x. So that's just taking care of those first two. We still have an x minus 1, and we have a plus 8. So right now we have this trinomial, x squared minus 2x plus 1 times x minus 1 plus 8. So in the previous videos, we did this using a lattice method. this trinomial, in other words 3 terms, times this binomial, in other words 2 terms. I want to go ahead and do this problem without that lattice method. Keep in mind, if you prefer lattice, you can absolutely feel free to do so. It's my preferred method for keeping track of the work, but you can do this without it. I'm going to start with that x squared and the x. X squared times x is x cubed. And we want to make sure we're multiplying every term in the trinomial by every term in the binomial. So it's going to walk down that trinomial. Now I have a negative 2x times x, which is a negative 2x squared. I then have 1 times x, which is a 1x. And now that I have gone through those 3 terms, I'm going to go back to the x squared and now multiply all 3 terms by the negative 1. X squared times a negative 1 and a negative x squared. Negative 2x times negative 1 is 2x. And the last one there is the 1 times the negative 1, which is negative 1. Note that there are 6 terms there. They're the same 6 terms that you would have seen if you were using that lattice method. This is just another way to do it if you prefer not to draw in those boxes. There's still a plus 8 that's hanging around. We don't want to lose that. And now we're good to go ahead and combine some like terms. So we have that x cubed at the very beginning. No like terms for x cubed. Sorry. We have a couple of x squared terms. We have negative 2x squared minus x squared. That'll give us a negative 3x squared. We also get this positive x, I think positive 2x. Well, if I have $1, you give me $2 more. That's $3. And then last but not least, we have our constant terms. Note that if you're using the lattice method, this 8 would not have been in your lattice. So you would have had to have that negative 1 and then add 8 to it as a separate step. Negative 1 plus 8 is going to be 7. And that is our first function composition problem. Good times. If you're currently looking at this like, holy cow, that was a ton of arithmetic, stay tuned. We're going to take a look at another couple that aren't nearly as much algebra going on as we had in this first example. We just wanted to take a look at this one to show you that this is how it works. We are taking one function, in this case it was g, the blue one, and substituting it into another function, which in this case was f, the green one. So we'll take a look at a couple more examples in the next video. They will be less intense than this one. So don't worry just yet. Go ahead and just watch that next one.